Okay, we're going to talk about section 3.3, which is solving systems by elimination. And so basically when you're solving a system of equations, what you're doing is trying to find the place where two lines intersect. And so this place where these two lines intersect is a solution that works for both of the lines. So we've got these two equations, 4x plus 3y equals 8 and x minus 3y equals 7. And if we want to solve that by elimination, then what we need to do is we need to add the rows together. And let me just show you what's going to happen when we start adding the rows together. 4x plus x turns into 5x. 3y plus a negative 3y, well, that's going to cancel out. And 8 and 7 turns into 15. Well, because we had a positive 3y and a negative 3y, they were opposites of each other, so that was kind of convenient in this scenario because it allowed for something to cancel out. They all don't work out as perfectly as that one. But now I can just divide by 5 on both sides. And so x ends up being 3. Now if I know x is 3, that's my first solution. Well, I need to figure out, well, what is y then? Okay, I can take either one of these equations and plug in what I know, which is x is equal to 3. So instead of x, so I just took the first equation. Instead of x, I'm going to plug in 3. I still don't know what y is. And so 4 times 3 is 12. I'm going to subtract 12 from both sides. So we're trying to solve for y, get y by itself. It's going to get me 3y is equal to 8 minus 12, which is negative 4. Divide by 3. And so y is equal to negative 4/3. So x is equal to 3 and y is equal to negative 4/3. So down here we've got an example where we have graphed both of the lines. So this red line and this blue line are basically graphs of both of these lines. The answer is going to lie right here where they meet, okay? And so we said x is 3, right? This is my x-axis, so if I go down at 3, and y is negative 4/3, which is the same as negative 1 1/3. Okay, so if I go to negative 1 and just a little bit more, right? That's where my solution, where those two lines meet. Now, can I check my work here? So I'm going to take the first equation, 4x plus 3y equals 8. And for x, I'm going to plug in 3. And for y, I'm going to plug in negative 4/3. So 4 times x, which is 3, plus 3. So I'm using these equations right here. So 4 times x plus 3 times y equals 8. Well, my y is negative 4/3. And I'm going to make sure that it equals 8. 4 times 3 is 12. These 3's are going to cancel out, so this is going to end up being 12 minus 4, which is 8. And so it works for this first one. Now I'm going to plug it into the second equation and make sure it works. So x, instead of x, I'm going to put 3. That's what x is. Minus 3 times y, which is negative 4/3. It's supposed to be equal to 7. And this negative 3 is going to cancel out with this 3, so this turns into 3 plus 4, which is 7. And 7 is equal to 7, so we know we're correct. Now let's look at this second example. This is not as nice because we don't have anything that just automatically cancels out. But what I do notice is I do have something that's already positive and something that's already negative. So if I can make both of these terms be the same thing, in other words, one be positive 10 and the other be negative 10, then I can do what we just did on the last problem. Well, I can make this 5 be a 10, but what it's going to take is for me to multiply this whole first row by 2. And so I'm going to basically use the distributive property and multiply every single thing in this row by 2. So we've got 4x, because we did 2 times 2x, plus 10y, 2 times 5y, and then 2 times negative 1 is negative 2. Now notice we kept the equal sign in the exact same place it was before. I'm just going to write the second equation right below it. Now we're going to take these two and add them together. So we've got 4x and 3x, that's 7x, 10y and negative 10y, that's going to cancel out and be 0. Negative 2 plus 16 ends up being 14. So 7x is equal to 14. We're going to divide by 7. And so we end up getting x is equal to 2. So now that we know that x is equal to 2, it's our job to find out what y is. And it doesn't matter. I could use this equation, or this equation. It doesn't matter. So I'm just going to pick this top one. So I'm going to, instead of x, I'm going to say 4 times, since I know x is 2, I'm going to plug in that 2. That's going to be 8 plus 10y is negative 2. Go to the side with the y on it. Get rid of the thing that's connected to the y. Negative 2 plus a negative 8, that's going to be negative 10. When I divide by 10, I'm going to end up with y is equal to negative 10 divided by 10, which is negative 1. Now, let's check and see. So this is the place, if we graph this, this would be the place where these two lines crossed. So if I'm going to use my equations up at the top and make sure that we're correct. All I've done is rewrite these down here. I'm going to let x equal 2 and y equal negative 1. Instead of x, I'm going to put 2. Instead of y, I'm putting negative 1, and it should be equal to negative 1. Well, this is 4 plus a negative 5, so negative 1 is equal to negative 1. That worked. It should be the same thing over here. I'm plugging in 2 for x, and I'm plugging in negative 1 for y. So this is going to be 6, a negative 10 times a negative 1, that's positive 10. So this is going to end up being 6 plus 10. So 16 equals 16. So we know that we're correct. Okay. Now this one's a little bit different. I do have my x's lined up, my equal signs lined up, my y's lined up, and my constant number lined up. But I don't see anything that's going to be really easy about this one. It looks to me like it's not going to be really easy to make this 2 be a negative 3 or this 3 be a negative 2. Same thing here. So what we could do is make one of these be a 6 and the other be a negative 6. So if we want to multiply the top row by 3 and the bottom row by negative 2, then we can get that to happen. We also could do the same thing with this and maybe make one of these be at 15 and one of them be a negative 15. There's lots of ways to work these problems, so you're coming up with a strategy to make one of them be a positive and one of them to be a negative of the same number. So I'm taking this 3 and multiplying it by every single thing over here. So 3 times 2x is going to give me 6x. 3, so then we have our equal sign. 3 times 3y, 9y, and 3 times 2 is 6. Then we're going to do the same thing with our negative 2. So it's going to be negative 6x. And then we've got negative 2 times 5y, which is negative 10y. And negative 2 times 4, which is negative 8. Okay, and now we can get something to cancel out. Now here's when people start kind of going, uh-oh, this is going to turn into 0, and they think they've got it wrong. You shouldn't be scared of 0. 0 is a number just like everything else. So if I don't have anything to put under this equal sign, I've got to put the 0 down. Before, we didn't put the 0 down because we actually had other stuff on the other side of the equal sign. But if there's everything cancels out, we're going to have to put a 0 over here. 9y plus negative 10y is going to be negative 1y. And then 6 plus negative 8, that's going to give us negative 2. Okay, so we're going to go to the side with a y. We're going to add 2 to both sides of my equal sign. That's going to give me 2 is equal to negative 1 times y. Then I'm going to need to divide by negative 1. And so y is going to be equal to negative 2. So there's one of our answers. Now recall, to find the other answer, I need to plug that in to either this equation or this one or this one or this one. It doesn't matter. Let's just pick the top one. So we've got 2x is equal to 3, but instead of y, I now know that y is negative 2. So 2x equals negative 6 plus 2, which is negative 4, divided by 2. So x ends up being negative 2. So these two lines would cross at the point, like if I drew an xy axis, these would cross at the point negative 2, negative 2. Now let's check these. So here's my first equation. I'm going to plug in negative 2 for x and negative 2 for y. Okay, this is negative 4. 3 times negative 2 is negative 6 plus 2, which is negative 4. So that one was good. Okay, my other equation says 3x equals 5y plus 4. And I'm still going to plug in negative 2 for the x and the y. Okay, so on this left side, I'm getting negative 6. On this side, I get negative 10 plus 4. So negative 6 equals negative 6. That checks out. So we know that that's the correct answer. Okay, we've got this one is a little bit easier, right? Because I've already noticed that at least these are both 2's, and there's no number in front of this, but this would be a negative 1, and this is a negative 1. So maybe what I should do is multiply, let's just multiply the top row by negative 1. That's going to make that be a negative 2. So we've got negative 2x. Then we do negative 1 times negative y, which is going to end up being a positive y. Then we've got our equal sign, and then negative 1 times 1, negative 1. And all I did was rewrite the bottom. Now watch what happens here. Negative 2x and 2x, if we add those, we get nothing, right? Positive y, negative y. If we add those, we get nothing. So we've got to have something on that side of the equal sign. So that is 0. Negative 1 and negative 3 is negative 4. Well, that's not true. 0 is not equal to negative 4. So in this case, there is no solution. When we graph these two lines would end up being parallel to each other. They never cross, and that's why there's no solution. The lines end up being parallel. They have a different y-intercept, but they're parallel. So no solution whenever we get a statement that's not true. Okay, so we've got 3x plus 4y equals 5, 9x plus 12y equals 15. There's a lot of things I could do here. I'm thinking maybe make this be a -9 if we multiply this by -3, and then those two would cancel out. So I'm going to multiply that whole row by -3. I could have also made this be a -12, so these would cancel out. There's more than one right way to do this, so I'm going to multiply each one of these numbers by -3. So -9x, -3 times 4y is going to be -12y, and then then we've got our equal sign, sorry, then -3 times 5 is -15. I'm just going to rewrite the second equation underneath here. -9x and 9x, that's 0. -12y and 12y, that's 0. So we've got to put something to hold that spot on this side of the equal sign. -15 and 15 is 0. So that is a situation where you have two lines that are exactly the same. So they're like lines that are on top of each other with the same slope and the same y-intercept. So this one ends up having infinite solutions. There's not a number that I could plug in for x and y that would not work, because every single point on that line is going to be a solution. So here is some steps to solving these. If you're a person who learns better with words, you can look back over that. And so we talked about some special cases, and one of the things we talked about was when you get to the bottom and you get something that is not true, we said there's no solutions, right? Those two lines are parallel, there's not any solutions. And another word people use for that is it's inconsistent, or that those equations are independent of each other. Okay? When we get to the bottom and we actually get something that is true, 0 is equal to 0, okay, we said we had infinite solutions. That's the word that we used in the problem above. Another word that they are going to use is it's consistent, and that those are dependent. They're the exact same equation. Okay, last example. The perimeter of a fence around the children's section of the community park is 260 feet. Okay, so we've got the perimeter of this fence measures 60 feet. The length is 34 feet longer than the width. Find the dimensions. So when you talk about perimeter, you go all the way around, right? So this would be the length and this is the width. So you would say length plus width plus length plus width ends up being 268. I'm getting that from my problem. Okay, so I could combine like terms here and say 2 lengths plus 2 widths is equal to 268. I'm trying to put a little tail on that L so it doesn't look like a 1. Then the other thing, we're solving a system of equations, so we need another equation. And so this says the length is 34 feet longer than the width. So basically, if we take the length and we add (34) to the width, then we're going to have the length. Now the problem with this and how you've been solving them, now there's another way to solve it where you plug this in, but the way we've been solving them today, we would need to have everything lined up. So we would want the length and the width on the same side. So I could do that if I just subtract W and say the length minus the width is equal to 34. So there's the first equation, and there's the second equation. I would have my L's lined up, and my W's, and my constant number, and my equal sign all lined up. So let's look and see what we've got. Sometimes it kind of helps just to write them right beside each other so you can see. Okay, so it looks to me like these two, one of them's already positive and one of them is already negative. So I could make this be a -2 really easily if I multiply this bottom row by 2. I'm just going to rewrite the top row. Now I'm going to multiply everything in the bottom row by 2. So 2L, 2 times -W would be a -2W. 2 times 34 is going to end up being 68. You know how I had that L looking like a T, so I had to fix that. So now I want to add those together because when I add them, that W should end up canceling out. So I would have 2 and 2, that's going to be 4 lengths. My widths cancel out because they turn into 0. 268 and 68. It's going to be 336. And then I want to divide by 4. And so 336 divided by 4. 336 divided by 4 is going to end up getting me 84. Okay. And so now that I know what L is, I'm going to use this equation too, just because it's handy. I'm going to plug that in. 84 minus W is equal to 34. Also, this one would have probably been even better because it just says 84 equals 34 plus W. Both of them would work, but I was just subtract 34. And 84, take away 34 is going to be 50. So W is 50. Okay, so we might want to just check and make sure that when we add all the way around that we're getting what we're supposed to get, which is 268. So we would have 84 plus 50 plus 84 plus 50. And so that is section 3.3.